Let's read through this rate, time, and distance problem. Moving sidewalks at Denver Airport, that's Denver International Airport in Colorado, move at 2.3 feet per second. Now, if someone can walk the distance of the sidewalk in 42 seconds when they're walking with the sidewalk, and if it takes them 114 seconds walking against the sidewalk, what is their normal walking speed? All right, well, I know this for a fact because a couple months ago I got stranded at Denver Airport for a couple hours, and what was I to do but to figure out how fast the moving sidewalk was moving. Matter of fact, I also figured out how long they were, and so I counted these sections of wall that were clearly, I forgot if they're 4 or 5 feet long, but I counted those. I think they're 4 feet long, and twice got 308 feet. I timed myself twice, and I got 2.3 feet per second, which is, well, not quite 2 miles an hour. But the idea is you step on these things, it's like an escalator going forward rather than up or down. And so if you walk with it, you just move faster. It gets you down the big concourse quicker. And a lot of airports have these moving sidewalks. Well, naturally I turned it into a word problem. And I must say I did not try walking against the sidewalk. I had my arms full of luggage, and I wasn't going to attract too much attention by trying to go against the stream, walking against the sidewalk. So I wasn't quite nerdy enough to try that. But anyway, this is good, valid information. Well, where do we start? Well, in rate, time, and distance problems, there are always 2 trips normally, and so one trip is moving with the sidewalk. So with the sidewalk, let's figure out the rate, time, and distance. Well, they're how fast is the normal walking speed? Let's say it's W. W is normal walking speed. And that's what we're trying to solve for. In other words, normal speed if you weren't riding one of these moving sidewalks. Well, if you're going with the sidewalk, it adds 2.3 feet per second to your normal walking speed. So the speed is W plus 2.3. This is feet per second. And times, how long did it take? Well, it took 42 seconds. 42 seconds. And that equals to the distance. Now the distance is measured in feet, isn't it? Because when we multiply these together, the units, second units, cancel, leaving feet. Distance is measured in feet. So the units are okay here. And against the sidewalk, what happens to the walking speed? Well, if you write 2.3 minus W feet per second, you're wrong, aren't you? Because, think about this. If you're not subtracting your walking speed from the sidewalk speed, it's the other way around. The sidewalk is subtracting from your speed because you're moving against it. So be very careful here. When you get any kind of subtraction or difference in a problem, the order of subtraction makes a big difference. And if you get them backwards, it's just going to mess you up. So you've got to slow down and think about those. This will be the person's walking speed minus 2.3 feet per second. Because, one more time, the sidewalk is subtracting from their walking speed. Well, and this takes, 114 seconds. So times 114 seconds. And the word seconds cancel. Again, leaving feet, and that was the distance. Now, I wasn't too specific over here because I knew, thinking ahead, that the distance was the same, so I didn't have to really put any algebra into the distance part, because these 2 distances are the same, and that's the secret to this problem. How do we relate rate, time, and distance? So we have speed times time equals distance for 2 different trips. In those problems, you always have to find a way to bring these two equations together. In this case, they're brought together because the distances are equal. It's not always true for all these problems, but it is for this one. So, I know I've got the right units, they're feet, that's a distance measurement. So then, I can set these equations equal to each other. I have 42 times W plus 2.3 equals to 114 times W minus 2.3. And there's our equation to solve. So I need to do a little racing in order to finish solving, but it doesn't look like a tough equation, does it? So let's go ahead and wrap it up here. And all right, I'm going to multiply through here. We could, I suppose, divide both sides by a number. If I divide 2 into here, I get 21. 2 into here, I get... actually, they're both divisible by 6. So let me shrink my numbers down. This is an optional step, but I like to shrink my numbers down. 42 divided by 6 is 7. So it's 7 times W plus 2.3 equals... 6 goes into 114, how many times? 19 times, doesn't it? 19 times W minus 2.3. So I figure 6 times 20 is 120, and this is 6 less than 120, so that's 6 times 19, isn't it? Well, in any event, I know you can use a calculator on this too. Multiply through here, I got 7W plus, oh boy, 7 times 2.3 is 16.1. Equals 19W minus, let me see, better grab a calculator, but I think it's 40, I don't know what it is. Anyway, 19 times 2.3 is 43.7. There we go. 43.7. So I'm just going to double check my 7 times 2.3. I'm pretty confident, but yep, 16.1. So let me see, I'm going to subtract 7W from both sides. 16.1 equals to 12W minus 43.7. I'll add 43.7 to both sides and get 59.8 is 12W. Divide by 12, and that looks to be very close to 5. 59.8 divided by 12 is 4.98. Why don't we round that off to 5? So W is equal to 5.0. I wrote 5.0 to indicate that it was rounded off to one decimal place rather than the whole number. Well, there we go. Let's write out the answer here, because I expect the sentence answer on word problems. The normal walking speed is 5 feet per second. There we go, 5 feet per second. And by the way, you can check it out. It's, we make the sidewalk 308 feet long. So I knew ahead of time it was 308 feet. And I made it 5 feet per second, which is around 3.5 miles an hour, I think. Right, well, anyway, that's the issue there. And we'll go from there.